Okay, so this video is basically going to be an additional video uploaded midweek. The reason I'm uploading this video is to basically help out anyone who's just struggling with the first lab activity for our topic, auxiliary projections. So you can see here, this is the question that's provided as you'll see it on the course website. After you've this printed out in A4 or A3, you can tie it down to your page like so. After that, what we need to do is identify what the question is asking. So it's basically asking us is to use auxiliary views to find the dihedral angle between the line and the surface of the object. So we have our line here, and here in plan. And then we have our surface of our object, which is represented in this triangle here, as well as represented as an edge view here. Now remember this triangle here, because you're looking down, this is plan. So this is our plan, this is our elevation. Because of that, we are looking straight down from above here in plan. So these lines here are put in as dashed lines because they're hidden detail of the shape of the square base pyramid turned upside down, as you can see represented over here in your pictorial. Now the first thing I would do is identify all the different points that you're going to be carrying to find this. So I know I'm going to be dealing with this surface here as well as this line. So I'm going to call this point 1, point 2, find them above here in my elevation. That's going to be 1 and this is going to be 2, and then I'm going to get my 3 corners of my surface itself. So 3, 4 and 5. So 3 is here in elevation and 5 is here and 4 directly behind it, like so. Now, what we want to do is we want to see, first of all, the surface that that line is lying on. We basically want to see that as a true shape. The reason we want to see that as a true shape, as soon as we can see that as a true shape, we can look at it at basically an edge view. And when we look at an edge view, then we can find the dihedral angle between that surface and this line. So the first thing we need to do is find that as a true shape. So what I'm going to do is I'm going to carry it in elevation and make an auxiliary plan down this direction, parallel to it, to find the true shape. My x1 y1 line, this is my xy line, and I'm going to carry all my lines, or basically all the different points that I need, across this line perpendicular. Like so. Now I'm going to take my distances from my plan down. I'm going to take my distance from my compass. So first of all, let's take for 1. So the distance from 1. Sorry, now I'm missing 2 lines here and here. So take the distance for 1, the xy line back, like so. Go to where 1 is carrying over, knock it off, mark it in as 1. Go for 2, and so on. Now again, this is where taking the numbers across with you, or basically annotating everything, comes in very handy. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Our surface is going to be 3, 4, 5. So we go 3, 4, 3, 5, 4, 5, like so. And then we have our line traveling from 1 to 2, like so. Now, do we know if 1 to 2 is basically a true length? We know that's not. It's still distorted. It's still an angle to us, so we know that's not true length, but we do know this is a true shape. So I'm just going to call this surface S. So I'm going to say true shape of S, like so. And I'm going to mark it as surface S below here as well. I will not indicate it as S here because it'll confuse because we're located in edge view. Now we have basically the true shape of surface S. What we need to do is basically look at this surface as an edge view to find the dihedral angle. Now what we're going to do is we're going to look at it at an angle that we're going to be looking perpendicular to this line, so we ensure that we have the right dihedral angle. So to do that, we're just going to take basically a new auxiliary, so our second auxiliary, which is going to be parallel with this line itself. Below here, like so. So this line is going to be parallel with this line here. Call it x2, y2. Again, all our points are going to come through that auxiliary, or that x2, y2 perpendicularly, like so. Let's see now. Like so, ensuring that you're taking every point as accurately as possible. Then what we're going to do is take our distances now from our x1, y1 back and knock them off below here. Just going to extend some of these lines. Like so. Take our distances again. Now we know that basically if this is going to be an edge view, so if we're going to see this surface as an edge view below here, we know that we'll need to have the same distance from x2, y2 line down for each one of these points. And the way that we know that's going to be perfect, so if I go back here, take for 3, it's going to be this distance. If I take it for 5, it's going to be this distance. If I take it for 4, it's going to be this distance. So they're all actually equal. So we know we're going to get a straight line, so we're looking at edge view of this surface. 3. I don't need to go back to take the measurement for 5 and 4 because, like I said, it's going to be the same distance, so you might as well keep it on the compass. 5, and that's going to be 4. Draw your line. It should be perfectly straight and also parallel with the x2, y2 line. Now what we can do is take 1 and 2 over. 1. There we go. We can see that's going to line the surface, so it's going to be the same distance again. So we know that actually where it intersects here is going to be 1. And then 2. This distance here, taken back and struck off, is here. And we join 1 and 2 together. And now we're looking at an angle that we can see our surface S as basically an edge view, and we're looking perfectly perpendicular to this angle here, so we can tell that this here is going to be our dihedral angle. So that there's your solution.